Okay, the intriguing part about the bonus is number 4 and the bonus question are the same concept. Okay, I just asked you like an extension. Okay, number 4, this is like when I showed you guys this, and we'll go back here, 1.6. When I ask you guys to check left side equals right side, that's what number 4 is. So what I want you guys to do is I want you to check to tell me if this point is a solution. Okay? There's lots of graphing going on. Okay? What we want to see is I want to see you check left side equals right side. And by that means, this is partially my fault. This is why we do formatives, right? It's not to necessarily see it is to see where you guys are at, but it's also to poke holes in what I've taught you, right? See if there's something that we've missed uniformly, right? This is one of the things, okay? So when we say left side equals right side, you're going to pick an equation. You have a left side and you have a right side to that equation, okay? So when I say check, I want you guys to go y equals 4x minus 7. I want you to check and tell me if the left side is equal to the right side. If it does, then you know you're right. Okay, so the left side in this question is just the y value from this point, 1. So 1 equals 4 times the x piece, 2, minus 7. 1 equals 8 minus 7. 1 equals 1. A lot of you did that. What we're trying to illustrate, though, is say left side equals right side. Okay? That's the gist of this question. Then you do the same thing on the other side, right? Or the other equation. 1 equals negative 3 times 2 plus 7. 1 equals negative 6 plus 7. Okay, this is just what we're looking for. If we say check, determine, check your solution, you want to say, therefore, it is left side equals right side. Is everybody okay? You guys did the same thing on the bottom. You identified, you took my word for the fact that this was the solution, and you plugged it in for x and y. Then you just solve for t and v. What most of you missed, and what I tried to emphasize, was the fact you had to rewrite the equations with t and v values. So after you found them, that's great. Okay, but I want you to write the two equations again with the t and v values plugged back in, so that you don't have t and v here anymore, you have numbers. Okay? If we look at number 2, do this quick, okay? This is standard. Oh, my pencil died. Okay, that's standard form. You want to switch it into y equals mx plus b. Okay? That basically involves just moving things one piece at a time. You're basically solving for y, and that's it. Right? Does that make sense? You guys have done that 110 times now. Sure. Some of you. Okay? So we're just going to go, this is in standard. Pencil's dead. And this is obviously y equals mx plus b. That's where you want to switch, right? So I want get y by itself. That's the gist of this question. Okay? So I'm just going to start grabbing things and moving it to the other side. Just trying to get y as close to being by itself as possible, right? So if I take, I'm just going to write the equation again. I'm just going to start grabbing stuff and throwing it to the other side. So I'm going to add 12 to both sides. So 2x plus 4y is equal to 12. Then I'm going to take the 2x, I'm going to move it over. So I got 4y is equal to 12 minus 2x, because I subtracted 2x from both sides. And I'm almost there, right? I just got to divide both sides by 4. Everything. And I land with y is equal to 3 minus 1/2 x. Does this look entirely like this? Almost, but not quite. It's saying the same thing, but that's it. Okay. I think this quiz does a pretty good job at representing what you're going to see on the test Friday from this section. Thursday, I keep mixing them up. Okay. The only other stuff I'm going to ask you is substitution elimination and how many intersection points there are. That's it. Okay. Any other questions with this? Okay.